Hello, good morning from wherever it is you're watching us from. And today I would want us to discuss about the concept of maintaining a healthy security posture. And I would want to start by discussing what a security posture is. And in my opinion, and a well-regarded one, a security posture is the overall strength and status of your defenses against cyber attacks. It is my submission that if you're a software engineer who writes applications that leverage on the internet to run, then it is incumbent upon you to maintain a healthy security posture. And you could start by heading to a resource like securityheaders.com for you to analyze a resource that you're maintaining or running, and that would give you a security posture. And most of them are balanced scorecards that will tell you a simple point system from, let's say, A to F. F being an extremely poor security posture status. So your aim should be getting it to an A or an A plus. Some platforms have gone ahead to even do A plus, just to show exemplary security posture maintenance. And some of the things I would want to urge developers to look at that would primarily deter or prevent the red teamers from actually looking and knowing how to attack you. And I'm talking about when I talk about red teamers, what we aim to prevent them from seeing is the results of open source intelligence, the results of scanning, fingerprinting your resources, so that they cannot easily enumerate any vulnerabilities or even know the kind of server you're running, any underlying technologies that could be vulnerable. You are basically putting a blanket on your assets. So I would want you to run to a resource like security headers. It's not necessarily the only free web application that could show you your security posture, but it is a good pointer as to where you are in regards to your status of the defenses and strengths of your web asset. So there are two types of applications. You will see an application like this and another one that looks like this. And your aim is to get at this point. So as a developer, what should you be looking at? And this is what you'll see when you try to evaluate your security posture. The key thing in terms of web applications which are running on web servers is to control the request response cycle, right? And one way you could do it is by controlling the headers that your site gives out. And number one, you could look at the aspect of implementing content security posture. This is the header that defines a policy that restricts the resources that a browser can load. For example, if you're running resources from a CDN, let's say you use CSS from Bootstrap, and it comes from a CDN like cdnjs.com or Cloudflare, and let's say you have a particular JavaScript like Moments.js that is running also from Cloudflare or CDN.js. So you need to only ensure that you can only run that resource that is coming from CDN.js and not from any other amorphous injected code from any other resource. So you may have your local resources, your local assets in your web application, and just a particular defined remote source of scripts that are allowed to run on your application. So even images, yeah, you could restrict from where your images are running from. And that is done through implementation of a CSP, or a content security policy. So the other thing is a referral policy. What a referral policy does, it controls the information sent out in the referral headers when a resource is requested from a different origin. And this is where the concept of cause or cross origin resource sharing comes in. How do you define? And people who develop APIs, you will have probably run into an issue of cause when you are developing an API backend from the local host to production environment. You most likely run into an issue of cross origin resource sharing. But it's extremely critical for you to define the referral policy. And later on, in these discussions of cybersecurity matters and concepts, we will be dissecting all these policies that we are talking about for you to maintain a reasonable security posture. So, number one, we said content security policy. Number two is a referral policy. Number three is a strict transport policy, or HSTS. So H stands for a header, but the rest is STS, strict transport security. So this is the header that tells the browser to always connect to the website using an encrypted channel, HTTPS or SSL. Yes. So even if the user has typed HTTP, what will be rendered it will force the browser to render the HTTPS version. So it is incumbent upon the developer to also know that my site is HTTPS enabled and it has an SSL certificate installed. The other thing is the X content type option. So this is the header that prevents the browser from guessing the content type of a resource. So if you're streaming music and you do not want the browser to know that this is an MP4 file, this is an MP3 file, or if it's an image, you do not want the response to show the MIME-type. You do not want to show this is an application PDF that we are returning, or this is a base64. So it's quite vital for you to hide this information. And you could say, for example, for X content type option, you could say no sniff. So that means, and that tells the browser, please do not look into the type of the resource I'm loading. And the requester could be a hacker who tries to see, let me try to guess the type of this, let me try to fingerprint the type of resources we are requesting when we hit this endpoint, so that they can go and try to look for any vulnerability related to that particular content type. So it's vital for you as a web developer or a software engineer who is leveraging on the web to keep track of that. The other thing is X-frame option. So this one controls whether a web page can be loaded into an iframe. And there's so many things that could go wrong in terms of getting your website loaded into an iframe. So someone designs an iframe locally and loads your site there, your URL there. So there are attacks that are called clickjacking. Yeah, someone could do a lot of things in an iframe in so far as your application is concerned. So it is very good to also implement the X-frame options. And finally, and this is critical, it's good to have a permissions policy. So you do know with the advent of HTML5, there's so many powerful APIs these days that can run on top of HTML5 and JavaScript. You can enable camera, you could enable geolocation, you could enable file sharing. It's critical that you define that my application will only request for location. Anything that tries to request for video or audio or file sharing, that is disabled. So for a comprehensive, a good security posture that you could feel comfortable with, it's important that you look at those uh, 6 or so factors that I've mentioned. And just to recap, number one, we said this is content security policy. You need to implement that in your applications. A referral policy, strict transport security, an X content type option, X frame options, and a permission policy. So with that, you're fairly confident anyone who is trying to run a scan, and you know this is the reconnaissance phase that red teamers will work on. So someone is trying to see what web server are you running, what technology are you running. So if someone identifies you're on an IIS server, you are on an Nginx server of a particular version, in fact, you could let them know that you're running on an Nginx server, but don't show the version. Because if you showed the version, then someone will try to go and look for a vulnerability that they can exploit. So, in a nutshell, every developer needs to look at the security posture of the web resources that they're running. And remember, when we talk over security posture, we talk about the overall strength and status of your defenses against cyber threats. So with that, ladies and gentlemen, thank you. Till next time, stay safe.